Hi there, my name is David Wood from Montreal, Quebec, Canada. I'm here to give you an overview on microphones for the first assignment of Coursera's Introduction to Music Production by Loudon Stearns. I chose microphones because they've always been something I didn't really understand very well. It's all been kind of nebulous, so I thought that this would be a good way to get over my misunderstanding or whatever of how they work. I got the material from the course, of course, and also from Wikipedia, the Shure website, which is pretty nice, and various forums and sites on the internet. So if I'm using anything that belongs to you that I'm not supposed to, just let me know and I'll take the video down. So that's it. Let's get started. A microphone is a transducer. It converts from one type of energy to another. Specifically, it converts sound pressure variations in the air to voltage variations in a wire. Let's go over the different types of microphones. The condenser microphone is also known as a capacitor microphone or electrostatic microphone. It is made up of an electrically charged diaphragm backplate assembly, which forms a sound-sensitive capacitor. When the diaphragm is moved by sound, the space between the diaphragm and the backplate changes, and this changes the capacity of the capacitor. This variation in spacing produces an electrical signal. All condenser microphones need to be powered to maintain a constant charge on the capacitor. This is done either by batteries in the microphone or by phantom power provided by a mixer or your audio interface. Condenser mics are more sensitive and can provide a smoother, more natural sound, particularly at higher frequencies. Be wary of using them on stage because they are susceptible to feedback. Should you do so, position them carefully with respect to the stage monitors. Condenser microphones are used in everything from telephone transmitters to inexpensive vocal microphones to studio recording microphones. This is my MXL V6 condenser microphone, which I'm using to record this voiceover. Apparently they don't make this anymore due to the high cost and low availability of several critical components. Condenser microphones are also available with two diaphragms that can be manipulated to provide a range of polar patterns or sound fields. We'll talk about polar patterns later. Dynamic microphones are made up of a diaphragm, a voice coil, and a magnet. The voice coil is surrounded by a magnetic field and is attached to the rear of the diaphragm. When the diaphragm is moved by sound, the voice coil moves, and its motion in the magnetic field generates the electrical signal corresponding to sound. Dynamic microphones use a basic construction and are therefore affordable and sturdy. They can handle extremely high sound levels and are mostly unaffected by extreme temperatures and moisture. Dynamic microphones are typically used on stage. They pick up sound in a specific area and thus are not very susceptible to feedback. This is my well-used trusty Shure SM58, a dynamic microphone that has served me well for almost 10 years in live settings. It's starting to look a little beat up. Maybe I should think about replacing it. But it keeps on ticking. Ribbon microphones use a thin, usually corrugated metal ribbon suspended in a magnetic field. The ribbon is electrically connected to the microphone's output, and its vibration within the magnetic field generates the electrical signal. Ribbon microphones are typically bidirectional. They pick up sounds from in front of the microphone and from the rear, but not the side. Some ribbon microphones allow you to alter the sound pattern using controls on the outside of the microphone. Here is the classic RCA Type 77DX ribbon microphone. Older ribbon microphones were pretty fragile, but that is not the case with modern versions, and dynamic range at lower frequencies has improved. Ribbon microphones don't generally need phantom power, although some have preamps which do of course require a power source. Use ribbon microphones for shrill or brassy sources, as they seem to smooth out those sources. You can also use them for vocals, live or not, when the singer isn't very close to the mic. A big ribbon mic has long reach. So we'll talk a little bit about some other microphone types that we might not necessarily use for recording, but just to cover some bases. Piezo microphones convert vibrations into an electrical signal and are often used as contact microphones to amplify sound from acoustic musical instruments. Lavalier or electret microphones are small, dynamic, Omnidirectional microphones used for television, theater, and public speaking applications in order to allow hands-free operation. They are most commonly provided with small clips for attaching to collars, ties, or other clothing. Different mics can be used for a wide variety of situations. SM58s, dynamic mics, pick up frequencies that are generally part of vocal range. Condenser mics tend to pick up all frequencies. If you look at the frequency response chart for a mic, you'll see what it picks up, amplifies, or rejects. The SM58 peaks at about 5 kHz and rolls off the bottom end. Here is an example of a vocal mic frequency response similar to an SM58. In this case, the peak is in the 2 to 8 kHz range to increase intelligibility for vocals. The AKG C414 condenser mic is flat and picks up everything. Here is an example of a flat frequency response. The polar pattern of a microphone describes what sound area it picks up well and what area it rejects. It's the sensitivity to sound relative to the direction or angle from which the sound arrives, or how well the microphone hears sound from different directions. The most common types of patterns are omnidirectional, cardioid, and supercardioid. A cardioid microphone has the most sensitivity at the front and is least sensitive at the back. Cardioid mics, such as the SM58, reject sound from the opposite side of the singer. This type of polar pattern is resistant to feedback and suitable for loud stages. Condenser mics can also be cardioid. Supercardioid microphones offer a narrower pickup than cardioids and a greater rejection of ambient sound, but they also have some pickup directly at the rear, so it is important to place monitor speakers correctly. Supercardioids are most suitable when single sound sources need to be picked up in loud environments. They are the most resistant to feedback. They are also useful when you want to capture less of the room. Omnidirectional microphones have equal output or sensitivity at all angles, which means they pick up sound from all directions. Therefore, the omnidirectional microphone does not have to be aimed in a certain direction, which is helpful especially with lavalier microphones. One disadvantage is that an Omni cannot be aimed away from undesired sources, such as PA speakers, which may cause feedback. A microphone with a figure of 8 polar pattern picks up the sound from in front of the microphone and from the rear, but not the side. Microphones with this figure of 8 polar pattern are typically ribbon or large diaphragm microphones. Microphone placement is a long topic, and I thought about including it here, but I've already gone long with this video, so maybe it could be a future topic unto itself. For now, I just say to follow the guideline given by Loudon in the music production course, which is to use your ears and place the mic where the sound source sounds good. That's all for now. Thanks for watching. So, recording this lesson was a learning experience. I apologize for going too long, first of all. It's the first time I've ever done a video like this, so I didn't know how much time the material was going to eat up. Also, sorry about the poor lighting conditions. I used Microsoft Movie Maker to put together the video, and it has its share of hiccups, for sure, so hopefully I'll get better at it as I go. Anyway, let me know if I left anything out or made any mistakes and so on. Any suggestions are welcome. Thanks for taking the time to watch and give feedback. See you soon.